Bismillahirrahmanirrahim. Welcome to Statistics for Data Science. In this lecture, we will explore statistical concepts, all essential for data science. We will also learn practical Python implementation to show how these concepts translate into the real world data analysis. So let's say we start with the descriptive statistics. Descriptive statistics involves summarizing, organizing, and presenting data meaningfully and concisely. The primary goal of descriptive statistics is to provide a clear and concise summary of the data to gain insights and understand trends, and distribution within the data set without making any generalization or inferences to a large population. There are different types of descriptive statistics: measure of frequencies, measure of center tendency, measure of dispersion, measure of variations, measure of position. In this lecture, we will discuss the first one, measure of frequency. Measure of frequency primarily refers to the count of how many times a specific value appears in a data set. It is also called frequency distribution. For example, here are 10 students registered in different subjects. So there are four number of students that are registered in Java. So we can present this data into frequency table or histogram or bar diagram. Here is table, mathematics is frequency 2. It means that there are two students registered in the mathematics. In statistics, there is one student. These concepts can be presented using the bar diagram. So this is actually the summarization of the data to present the data in a compact, meaningful way. Relative frequency. Relative frequency primarily refer to the proportion or percentage of the total observation that a particular value or category represent. How often some things happens divided by the all numbers. So here is the same previous table of the subjects and the registered students. So this is the relative frequency. Total, there are 10 students. If we divide the 2 by 10, we get 0.2. So it means that there are 20% of students registered in mathematics, and there are 40% students registered in Java. So we can use this relative frequency to present the data, count data, and we can use this for comparison purposes. We can easily compare two different data sets having a different number of total values. Cumulative frequency, the sum of frequencies for all values up to the certain point in a data. This is actually running total of frequencies within a data sets, adding up the number of occurrences of the values below a specific point in the data sets. Here is a frequency distribution of student scores. And with the frequency, there are 10 students having a score from 10 to 19. Uh, Cumulative frequency is 10. There are 10 students in the first group. Then for the second group, the cumulative frequency is 25. It means that there are 25 number of students having a score from 10 to 29. Similarly, there are 37 number of students having a score from 10 to 39. So we can use the cumulative frequency for identifying the medians, quartile, understanding data distribution over a range. Cumulative relative frequency. The cumulative relative frequency, it is the accumulation of the previous relative frequencies, which is expressed as a proportion or percentage. Here is the table of student scores. This is the cumulative frequency, and its relative frequency is this one. So again, we are dividing by the total the frequency. So first, for the first group, relative frequency is 0.20. It means that there are 20% of students having a score from 10 to 19 and so on. So it can be used for the frequency graph guides to identify percentiles. Application of Mayra frequency in real world, public health. We can use the Mayra frequency for the in the public health, counting the number of disease cases in different region to monitor outbreaks. For example, COVID-19 cases by day or region. Similarly, in market research, we can measure the user or customer preference, uh, analyzing customer preference, frequency of purchases for different products. In education, we can use for examining score distribution across 25 common score range. AI is a data that we will implement this data to calculate the frequency, relative frequency, cumulative frequency, and so on. So let's say we use this data into the Python, how to calculate the data. So here is a our mm, so this is the data sets. First data sets, there are 20 students. Now to for first time we will import the Panda package. And for example, data frame is equal to pd dot data frame. So data one. So this is the actually data. So if we want to display the data, so this is the given data in which there are 20 students. Now to calculate the frequency, absolute frequency, so we can use the df this marks and then value uh, count count values uh, value value counts and then frequency. So we can get this is a so here the frequency distribution 15 having a frequency 4, it means that there are 4 number of students having a marks 30 and there are 3 number of students having a marks uh, the 30 and so on. Now to calculate the relative frequency, so here relative frequency, for example, is equal to um, df marks and value uh, counts value counts, and now to normalize the data so we'll get the relative frequency. For example, now relative frequency will be equal to, so this is the relative frequency. There are uh, 20% of student having a marks 10. Now cumulative frequency. So cumulative frequency, let's say this is the cumulative frequency, df marks and value uh, value counts. Just use the mm, cumulative cumulative sum function. So we will get the cumulative frequency table. So this is a cumulative frequency table 4 to 7. which is actually the running total of the frequency within the data sets. Now, to calculate the cumulative relative frequency, so just to normalize this, so we will get the cumulative relative frequency. So this is the cumulative relative frequency. So in this way, we can get the cumulative relative frequency. Similarly, if you want to use the second data set, this one, beverage, so we can follow the same procedure. The same methods, the same function can be used. So this is, for example, data set 2, beverage and value count. So you will get this coffee. There are 4 persons ordered coffee and 340 and so on. So in this way, you can apply the other functions. Now there is uh, another data for practice. So you can use this for practice to get the here is a so you can use this data to get the following result. Okay, so